Lesson 5 is order of operations, but with radicals and rational exponents. Before I get started, I just kind of want to warn you, these problems are not the easiest problems in the world, so don't feel bad or anything if you need to like rewind and rewatch any of the examples. And then also some of the steps I'm going to be doing a little bit differently than like the written steps in your workbook. So if you want to kind of see a different way of approaching the same problem, you can check those out and kind of compare and figure out which way works best for you. So 5.1 is expressions with radicals. And then we're going to be using order of operations today, which is like PEMDAS or like the please excuse my dear Aunt Sally is kind of the way we usually remember it. But the first order is parentheses or other sorts of grouping symbols, which can be like fractions. Like for example, if you looked down at number 1, there's a fraction right here. So we would consider that a grouping symbol because it's kind of arranging them together. So that would go with step 1. And then 2 is exponents, and then also radicals can be written as exponents, so radicals would be put in that category as well. 3 is multiplication and division, so whichever comes first, left to right. And then last is the addition and subtraction, same thing, whichever comes first from left to right. So getting started with the first example, this one goes with workbook 5.1. So I have from left to right, the square root of 81 over the fourth root of 81 minus 8 times 2 plus the fourth root of 625. So first step is to look for any parentheses or grouping symbols. I don't have any parentheses, but I do have this fraction here, which we can consider a grouping symbol. And so we just kind of want to work on simplifying that first. So for the square root of 81, the numerator, I know that's 9, but I may not know the fourth root of 81 as easily. So remember, if you have like a radical that you don't know, kind of one of the best places to start is by making a factor tree for that radical. So I'm going to do it off this side. I'll make a factor tree for 81. And then I know two numbers that multiply to 81 would be 9 times 9. And our goal is to work down until we get to our prime numbers. So like two numbers that multiply to 9 would be 3 times 3. And then after the 3's, we stop because 3's are prime, meaning their only factors are 1 and 3. So I wouldn't go any further, otherwise the tree would never end. So I'm looking at just the prime numbers at the bottom, which are all my 3's. And then since this was a fourth root, instead of looking like for pairs like I would with a square root, I have to look for 4 of the same number. So this is essentially saying that if I take 4 3's and I multiply them together, or I do 3 to the 4th power, that equals 81. So that means that the fourth root of 81 would be 3. So 9 over 3, and then I'm going to copy down the rest of the problem and just take it step by step. And that's my biggest piece of advice is it starts off with a lot of steps at first, but you never have to do more than one at a time. Sometimes you have to write the lines of the problem kind of a lot, but you can just focus on one piece at a time and it'll eventually work itself out. Okay, and then next, we're still kind of working on that grouping symbol aspect of it because we still have a fraction here that we can simplify. So that 9 over 3 is just like 9 divided by 3. And if it was like a regular division sign, like this, I would probably just leave it for now. But since it's written as a fraction, I'm just going to go ahead and divide it right now because a fraction is kind of like, or it is a grouping symbol like parentheses. So I'm just going to divide 9 divided by 3 to get 3, and then copy down the rest of my problem, minus 8 times 2 plus the fourth root of 625. And then I don't have any more grouping symbols, so I can move down to the second part of my order of operations. So the next one is exponents or radicals, because radicals can be written as exponents. So this is my radical, and the fourth root of 25. Same idea as like the fourth root of 81. You may not know that off the top of your head, but you can definitely make a factor tree for it. So I'm going to do 625. And then any number that ends in 5 is divisible by 5. So if I do 625 divided by 5, and you can use a calculator for if you want, you get 125. So that means I can do I can do 5 and 125 as two factors of 625. And the 5, we would stop there because it's prime. The 125, that number ends in 5 also, so I can take 125 and divide it by 5 and get 25. So 5 times 25 is 125. And then 25 would be 5 times 5. So again, just looking at the prime numbers at the bottom, and then this is the same where it's a fourth root, so I would need 4 of the same numbers. And what this factor tree is saying is that I have I have 4 5s being multiplied together, or I'm taking 5 to the 4th power, and that's equal to 625 because I had 1, 2, 3, 4, 5s down at the bottom of my tree. So if I take the 4th root of 625, I get 5 because 5 to the 4th power is 625. And I'm just going to copy down the rest of my problem. So 3 minus 8 times 2 plus 5. I'm going to move that 5 over. And then there's no more radicals, so I can move down to the next one, which is multiplication and division. I just have this one multiplication symbol, so I just have to do that part next. So I'll do 8 times 2. So it'll be 3, and then minus 8 times 2 is 16, plus 5. And then no more multiplication or division symbols, so I'm moving on to the 4th step in the order, which is addition and subtraction. And this is a good example of whichever comes first. So I would just look at the problem from left to right. So if I'm looking from left to right, first is the subtraction symbol, and then second is the addition. So I'd have to do the subtraction first. So I'm going to subtract 3 minus 16 first. So if I do 3 minus 16, that's negative 13. And then I have to make sure that I copy down my plus 5 after. And then now I just have that addition, so I can go ahead and add 13 and 5, or sorry, negative 13 and 5. And when you're adding like a positive and a negative number, you really just find the difference between them. So like the difference between 13 and 5 is 8, and then you take the sign from the larger number. So this would be a negative 8 since the 13 was negative and it was bigger. So final answer is negative 8. And if you want, like if you're pretty comfortable with this stuff, you can do this in less steps, but just try to kind of recognize or get in the habit of like, if it does go overwhelming, just pick one thing to focus on at a time and it'll eventually work itself out. Okay, so 5.2 is expressions with rational exponents, which is just fractions. This one I definitely kind of approach a little bit differently than like what it looks like in your like written workbook. So if you want to check out a different way to do it, you can look at that, but it kind of like giving you guys options. So the first thing we have to focus on is grouping symbols. So there's not really parentheses, like that 5, 6, and 5 to the 6th power inside parentheses. We won't really consider that because there's not much to do inside of it. But I'm gonna simplify like that grouping symbol. So I'm gonna bring down the 625 to the 1/8 power, and then divided by, I'm just going to go ahead and simplify this part next, so the 6 to the 1/3 power, and that's like a power to a power, so I'd multiply those exponents, so I would do 6 times 1/3, which 6 times 1/3 is 2, so this becomes 5 to the 2nd power, and then over 5 to the 1/2 power, and then minus 2 divided by 10. And then I'm going to keep trying to just simplify down this like fraction or grouping symbol. So now I have a like quotient where I'm dividing and they have the same base. So I would subtract the exponents. So in order to subtract the exponents though, I need to get a common denominator between 1/2 and 2. So I'm going to change that 1/2 to, or sorry, I'm going to change that 2 into a 4 over 2. I'm going to multiply by 2 over 2 to give myself a denominator of 2. I can think of that 2 as 2 over 1 if I want. So I'm going to bring down this 625 to the 1/8 and then divided by 5 to the, if I just multiply straight across here, it's 2 times 2, so 4 over 2, and then over 5 to the 1/2, and then minus 2 divided by 10. And then now I can go ahead and subtract these exponents. I'm going to backtrack a little bit just to kind of talk about what we did that last step one more time. So in the numerator, I had like 5 squared and I needed to get a common denominator with the 1/2. So I just changed that squared into a 4/2 because 4/2 is equivalent to squared, or like to the second power. I just had to get the common denominator. So now I have the same base, 5 and 5, and I'm dividing them, so I would subtract these two exponents. So I'm going to copy down my 625 to the 1/8, and then divided by, if I subtract 4/2 minus 1/2, I just have to subtract the numerators, the ones on top, so I get 3/2. So 5 to the 3/2 power. And then minus 2 divided by 10. And then my grouping symbol part is like kind of simplified now because I don't have any more fractions. So I can move to step 2. I'm going to zoom out for a second. So step 2 was exponents or radicals. We don't have exponents, or sorry, we don't have radicals here, but we do have these exponents. So I'm going to work on the 625 to the 1/8 next. I'm going to see if I can do anything there. So I'm not sure if I can take the 8th root of 625. It seems like a long shot, but I'm going to make a factor tree for it. So for 625, we made a factor tree for 625 up here, so it's going to be the same thing. But 2 factors of 625 are 5 and 125. And then at the 5, we would stop because it's prime. For 125, it's 5 times 25. And then for 25, it's 5 times 5. So I have 1, 2, 3, 4, 5s again. And in this case, so I'm going to just kind of make a little side note over here, or you can write it into the problem if you want. Remember that if I raise something to like a fraction exponent, it's the same thing as a radical. So 625 to the 1/8 power is the same thing as the 8th root of 625, right? So it goes back to, I'm going to write it up in the upper corner up here, that kind of formula that we use to change between the two. So if I have b to the e over r, it becomes the r root of b to the e power. So in this case, like r is in the denominator, e is in the numerator, b is the base. So r is 8, b is 625, and then there was e was 1, so if it's a first power, I don't necessarily need to write that part. I can just leave it off. Okay, so since we're taking the 8th root of this number, essentially, we would be looking for 8 of the same numbers right here, and we only have 4. So that doesn't really do me any good, but I'm gonna go ahead and kind of at least take the work that I did and do something with it. So 4 5s means 5 to the 4th power. So I'm just going to go ahead and replace like my 625 with 5 to the 4th power because these are equivalent. We just kind of broke it down to its primes. So I'm going to replace 625 with 5 to the 4th. And then that's the 1/8. And I'm just going to copy the rest of the problem down. So divided by 5 to the 3/2 minus 2, and then divided by, it looks like I forgot the 0 on the 10 up here, or accidentally erased it at some point, but minus 2 divided by 10. So before we go on to the next step, I just kind of want to point out is like that last step didn't really work out the way we wanted it to, but we still made progress on the problem. So keep that in mind. Okay, so for the next step, now I have right here a power to a power. So I have 5/4 to the 1/8. So when I have a power to a power, I multiply those exponents. So if I multiply 4 and 1/8, it would become 5 to the 4/8. And then I'm going to copy the rest of the problem down. So divided by 5 to the 3/2. And then minus 2 divided by 10. So stick with me. I know it's not the easiest problem in the world, but we're ready for the next step, okay? So now we have a bunch of like division and looks like subtraction. Sorry, just division and subtraction. And this is kind of like getting into properties of exponents like territory because we're dividing with powers that have the same base, right? So they both have the same base, 5 and 5, and they're dividing them, so we can subtract the exponents. But I can't really subtract the exponents as is because they don't have a common denominator, but that 4/8 is the same thing as 1/2. Like 4/8 and 1/2 are equivalent if I just divide numerator and denominator by 4. So that's what I'm going to do. I'm just going to replace that 4/8 with a 1/2. And you can do that too, like instead of like rewriting the whole line, like just erase the 4/8 and put a 1/2 once you realize it's the same thing, just to save yourself a little bit of writing. And then now, like I said, same base, the like 5 and the 5. So we're going to subtract the exponents. That's my really long subtraction symbol. Okay, so 5, and then it'll be 1/2 minus 3/2. So 1/2 minus 3/2 minus 2 divided by 10. We're getting closer. If I do 1/2 minus 3/2, I just need to subtract the numerators. So 1 minus 3 is -2. So 5 to the -2 halves, which remember when you add or subtract fractions, the denominator stays the same. So that 2 stays the same. And then I'm going to copy down the rest of my problem. So -2 divided by 10. And then hopefully you'll recognize, okay, -2 over 2, that exponent, -2 over 2 is the same thing as -1. So I'm just going to erase that. I'm going to replace it with a -1. And then I remember, miraculously, from a previous lesson, hopefully you do too, that when we have a negative exponent, we take the reciprocal of the base. So the reciprocal of the base is 1/5. It would become 1/5 to the first power, but we don't need to write that first power. So 5 to the negative first power is equivalent to 1/5. And then I'm going to copy down the rest of the problem. So -2 divided by 10. And now it's starting to finally clean itself up. So I have subtraction and division left. So division comes before subtraction. So I'm going to do division. So I have 1/5 and then -2 divided by 10. I'm going to write that off to the side. I'm going to write it over on the left just because I don't have that much space. So I can rewrite 2 divided by 10 as 2 over 10. And then all of a sudden that's like a fraction that I can reduce. And I would prefer it as a fraction as opposed to a decimal. So I can divide both of these, numerator and denominator, by 2. And then when I do that, it becomes 2 divided by 2 is 1, and 10 divided by 2 is 5. So 10 divided by 2 is 1/5. So this whole thing turns into a -1/5. And then I have 1/5 minus 1/5, which is 0. So after all that work, it's just 0. Okay, so same thing I said before. Biggest suggestion is just to like take it one step at a time. And there was parts during this problem where like we really didn't like accomplish what we were hoping for. Like when we tried to take the 8th root of 625, we made a factor tree for it. And we didn't. We weren't able to take I think I said 6th root, but we weren't able to take the 8th root is what we were looking for. But the work that we did with the factor tree set us up for like being able to use the power property over there. So it still like made progress, even though it wasn't really the progress we were hoping for. Okay, and then 5.3. So expressions with radicals and rational exponents. So now we have both. So same strategy, take it piece by piece. So we have the square root of 243 to the 4/5 power divided by 4 to -1/2 power over 2. Okay, so at the beginning of order operations is parentheses or like grouping symbols. So that would kind of mean in this case, so we do have the parentheses here. I'm going to save that for a second. I just kind of want to talk about the grouping symbols in general. It's just like we want to make sure that we simplify like this entire numerator first before we do anything with the denominator, because like all that numerator is grouped together. Okay, so first thing I'm going to do is I don't like having this radical, well, okay, first of all, the square root of 243 is not a perfect square. So like it's like not, if I take the square root of it, I would get a decimal. I wouldn't get a nice clean answer. So I'm not going to take the square root of it. I don't like how the square root of 243 is a radical and this 4/5 is a rational exponent. I don't like how they're in two different forms. So I want to get them in the same form. So anytime I have the square root of something, that's the same thing as the 1/2 power, right? Because like the root is 2, the exponent is 1. So it'd be like b, r would be 2, e would be 1. I have the formula written over here as well. Oops, not supposed to be a circle, but I have the formula written over here as well, just to kind of remind you. That's something like I would, this entire chapter, I would just keep like on a sticky note or like a sheet of paper in front of you because it's so handy to like know that and be able to change back and forth really quickly. So I'm going to rewrite the square root of 243 as a fraction exponent. So the 243 is the base. The square root goes in the denominator, so it'd become 2, and then the exponent, which I know there wasn't an exponent there, so if there's no exponent, it's a 1. That goes in the numerator. So the square root of 243 is the same thing as 243 to the 1/2 power, and then that is still being raised to the 4/5 power, because I had this 4/5 right here. Okay, and then I'm just going to copy the rest of the problem down because that was enough for one step. So divided by 4 to the negative 1/2, and then that is over 2. Okay, and then the next thing we can do is now we have a power to a power, so I can multiply those exponents. So I'm just going to kind of copy down this little fraction bar. So it becomes 243, and then I have these two like power to a power, so I'll multiply those exponents, so it become 1/2 times 4/5, and then divided by 4 to the negative 1/2 over 2. And now I'm gonna try to zoom in so it's like a little bit easier to see. And now I can go ahead and multiply these exponents. So we can multiply straight across and then reduce, or we can cross cancel. So the 4 and the 2 have a common factor of 2, so I'm going to divide them both by 2. So if I divide 2 by 2, that becomes 1. If I divide 4 by 2, that becomes 2. And then now I can multiply straight across. So this is going to be, I'm just going to go to the next line. I'm going to start going sideways. And scratch that. I'm going to go down one more. Sorry. Okay. So 243. And then I'm going to do 1 times 2. So 2. And then over 2, or sorry, over 1, because it became a 1, times 5. So over 5. And then divided by 4 to the negative 1/2 power over 2. Okay, so we have 243 divided by 4 to the negative 1/2 power, and then over 2. I'm still just going to keep working on that 243. I'm pretty committed to like getting that part out of the way. So now we have to kind of remember, I'm just going to do a little side work over here. So 243 to the 2/5 power. If I wanted to put that in a radical form, the b would be 243, the e would be 2, the r would be 5. So as a radical, it would be the 5th root of 243 inside, and then to the 2nd power. Okay, so I don't know, but there's a chance that there is a 5th root of 243, so I'm going to try to find that. So I would make a factor tree for 243, and it's not even, so it's not gonna be divisible by 2, but I'm gonna try to divide it by 3. So I would use a calculator and do 243 divided by 3, and it's 81. So it'd be 3 and 81 as factors of 243. And like I said, you don't have to know that, you just need to like guess and check with the calculator. 243 was not even, so the next factor I tried was 3. I did 243 divided by 3, and it gave me 81. Okay, and then I know 81 is like 9 times 9. And then we're just going to keep going until we get to only primes. So 9 is 3 times 3. And then the other 9 is also 3 times 3. And then after the 3's, we stop because those are prime numbers. So I'm looking at all the prime numbers at the end. So I have this 3, and then I have these 4 3's down here. So I have 1, 2, 3, 4, 5 3's. So it means 3 to the 5th power is 243. So that means that the 5th root of 243 is 3, because 3 to the 5th power is 243. And then I just can't forget about this exponent right here. I have to still bring that down, so I'm going to bring down that squared part. Okay, so we just basically took 243 to the 2/5 and we simplified it. I like kind of doing it off to the side because with the factor tree it just gets like really involved. But now I'm just going to take this, like we simplified the 243 to the 2/5 power, we changed it into a radical form, and then we simplified that radical to this. So I'm just going to pop this in here. Okay, now I'm going to bump this up because I kind of ran out of room. Okay, so that 3 squared, that's going to replace the 243 to the 2/5, so 3 squared, divided by 4 to the negative 1/2 power, and then that's over 2. And then now I'm going to zoom back in. We can go ahead and simplify the 3 squared. That's pretty straightforward. 3 squared just means 3 times 3. So that's 9. I'm going to copy the rest of the problem down. So 9 divided by negative 1/2 over 2. And then from there, it might be easiest to do this next part off to the side as well. Sorry, I keep having to do stuff off to the side, but I think it's a little bit easier that way because it kind of keeps your like main line of work more clean. It's entirely up to you though because it's your scratch work. Okay, so what I'm going to do is I'm going to take this 4 to the negative 1/2 power and I'm going to kind of simplify that off to the side. So 4 to the negative 1/2 is, 4 to the negative 1/2 power is whenever we have a negative exponent, we take the reciprocal of the base. So it basically means we take the 4, we can think of it as 4 over 1, and then we flip it upside down. So it'd become 1 over 4 to the 1/2 power. And then remember, anytime you have the like square, or sorry, anytime you have a 1/2 power, it's the same thing as the square root of that number. So because my like b is 4, and then r would be 2, e would be 1. So this would simplify into 1 over the 4 would go inside the radical, and then the type of root would be a 2 or a square root. You don't need to like write the 2 there, but you definitely can if you want to. And then the exponent e would be 1, so you don't need to write that either, but you can if you want to. And then the square root of 4, of course, is just 2. And then I have that 1 in the numerator. So we took that 4 to the negative 1/2. I just popped it out here to simplify it just to keep it a little bit cleaner. But it simplified to 1/2. So I'm going to replace that 4 to the negative 1/2 power into 1/2, like just 1/2 altogether. So it's going to be 9 divided by 1/2 over 2. So the 4 to the negative 1/2 just got replaced with just 1/2 because that's what we simplified that 4 to the negative 1/2 to on the right side. Okay, and then we're getting closer. So now we're still working on simplifying just that numerator because that's kind of the thing about like grouping symbols is like this is all together on the numerator. It should be simplified first before we do anything with the denominator. So usually instead of dividing fractions like this is 9 divided by 1/2, we change it to multiply by the reciprocal. So what that means for our next step would be the 9 stays the same. So it'll be 9. And then instead of dividing, we change that to multiplication. And then the reciprocal of 1/2, so it becomes 2 over 1. But 2 over 1 is just 2. So we can just write it as 2. If it the numerator wasn't 1, we would solve a fraction there, but it was, so we can just write it as 2. And then we need to bring down the 2 that was in the denominator, so there's a 2 down here. And then now, a couple ways that we can approach it here, but we basically just have like 2 more steps, 1 more step maybe, depending on how you look at it. So one option is from here, we can just go ahead and multiply straight across. So this would become 9 times 2, which is 18. Copy over the 2, and then we have 18 over 2, which is just 18 divided by 2, which is 9 for our final answer. The other approach that we could have taken from this step right here is if we kind of recognize that we had a 2 in the numerator, like a 2 factor in the numerator, and then a 2 in the denominator, we could have technically just like kind of canceled each other out because it's like 2 divided by 2, and then we would have just been left with 9, which is what our final answer was with the other method. So it's really up to you. Okay, so final answer was 9. Again, I know not an easy problem, so feel free to like watch it again, watch it as many times as you want. But yeah,